or gets to listen to you guys today. 10.3, trend lines. We're going to learn how to put trend lines on scatter plots. Some vocab that we already have talked about and have written down the formal definition for earlier. Basically, when you look at this, a trend line, a line of best fit, a linear model, those all represent the same thing. All right, the line of best fit is what you're going to learn how to do today. The slope, well, we all know slope, we find it with rise over run, or in slope-intercept form, y equals mx plus b. Which one is your slope? The m is your slope. Which one is your y-intercept? The b, the y-intercept. And that's always, what were we referring to it also? When we graphed it, on the test, what did you start out with? Initially, what was your beginning starting point? That's your y-intercept right here. All right, the first thing I want to do is show you another one. I want to show you one of those Learn Zillion videos. This is a really good one. I like this one. It explains how to draw a line of best fit and how not to. I like the different examples. Just a short little video from Learn Zillion.
Can we say that data points make a line when their points are not in a perfectly straight line? For example, would you say the data points on this graph make a line? In this lesson, you'll learn to construct a line of best fit for bivariate data by creating a scatter plot. Let's review. A scatter plot is a graph of plotted points that helps illustrate the relationship between two sets of data. Here's a few examples of some scatter plots. A scatter plot uses bivariate data. Bivariate data is data that shows a relationship between two variables. On this scatter plot, our two variables are age and height. The scatter plot shows a relationship between a child's age and a child's height. Here's the data chart of a children's height, and here's the scatter plot that goes with it. Looking at the scatter plot, do we see a pattern? There's definitely a pattern known as an association. The pattern appears to make approximately a straight line, so therefore we could say it has a linear association. If we take a ruler or straight edge, we could draw the line to the middle of the data points. This line is known.
Okay, on this I'm going to give you a little pointer right there. He took his ruler and laid it down. I'm going to give you a protractor because they're clear, you can see it. And instead of laying your protractor flat, hold it up on its edge. And that way you can look and see how many dots are in each side. Instead of laying it flat, lift it up, hold it up on its edge, and look down upon on it. Makes it easier to see where your line of best fit is at.
Known as a line of best fit. We can use this line to help show the pattern of the relationship between a child's age and a child's height. A line of best fit should extend all the way across the graph. On this scatter plot, my line of best fit is not big enough. I want my line of best fit to go from one side of the graph to the other. There. That's a better line of best fit. A line of best fit should also reflect the pattern. So just because my line goes all the way across the graph doesn't mean that it reflects the pattern. This line of best fit isn't a true reflection of the pattern of the data. The pattern looks more like this. So my line of best fit is no good. There, that's a better line of best fit. A line of best fit should also be centered between the data points. This line of best fit is not bad, but I should have about as many data points above the line as below the line. This location of the line of best fit is just a little too low. It needs to be moved up. There, that's a better line of best fit. Let's review. A good line of best fit should extend across the graph, reflect the pattern, and be centered between the data points.
Okay, if we look at that one, is that a good line of fit? Best line of fit?
Good.
All right, it reflects the pattern, extends across your whole graph. Is it pretty equal? It's touching 1, 2, 3, 4, 5 dots. How many above it? 1, 2, 3, 1, 2, 3, 4. That's pretty much dead on, isn't it? That's a pretty good one. Because there's equal amount of data points on each side of that point, of that trend line.
A common misunderstanding is to assume that every scatter plot is going to have a line of best fit. This line of best fit doesn't really reflect the pattern. Neither does this one. Not all scatter plots will be able to have a line of best fit. On this scatter plot, there's really no pattern visible, so there's no association. If there's no association on the scatter plot, then there's no line of best fit. In this lesson, you have learned to construct a line of best fit for bivariate data by creating a scatter plot.
All right. Thank you.
Can we say that data points
I want to start it again. All right, now I've passed out a protractor for each of you to use as a straight edge. That way, then they're clear, you can see through them, and you can hold them up on their edge. All right. So everybody should have one of those at their desk now. Make sure those don't leave the classroom. Put them back in the tote here when you're done with your homework. Now, using your protractor for your straight edge, we want to draw a line, a trend line for graph A. Well, let's see. If I put my trend line, where do I want to kind of go from? Maybe this point to that point? Extend it all the way through the graph? How does that look? Could I do better? And I'm going to give you a little hint. Later on, we're going to be finding the slope and the y-intercept and writing the equations. So if possible, if you can get your trend line to go on 2 points that are at nice little intersections to use for your x and your y coordinates, it's kind of a nice little hint. How about there? Did I get my trend line pretty even on that? Yeah. Is it? I've got 1 point above it. How many below it? 1, 2, 3. So is that the best line of fit? No. It follows two things. It extends through the graph and it goes with the pattern, but could I move that a little bit? How about there? And there. What if I use those 2 points? Oops. Is that the same one I was just using? I meant to slide it. How about that? Better? Yeah. Now we have 2 over here and 2 under here. That's a little bit more even. So you see how you want to adjust your protractor and you want to move it, your straight edge, until you see where should that line go so there's it's centered and there's pretty close to equal points on both sides. How about over here? What points do you want to go from here? Is that good? 1 and 2. Scooch it over a little bit. Is that pretty good? 1 on this side, 2 on this side, and it's actually going through 3 points. Not bad. How about if I moved it here? Would that be better or worse? That would be worse. It's better here because now I'm at 2 and 3. Or excuse me, 1, 2 on this side and goes through 3 points. All right? How about C? No association I'm hearing. That is true. We cannot do that one because there is no association. It doesn't matter how you go through it. You can't see an association. So that one is not possible. This one is no association. So there will be no trend line. All right, how about this one? how'd I do? Is that good or can it be better? Can it be better? How about there? Better? No? So you want to go from here to here? This one? You want to keep this one?
Start at 5 for your y.
Start at the 5?
Then you're
Yeah, I do my two middle
then
ones
go
first
to
like that.
9,
Yeah.
9.
So if I do two middle ones and I go 1, 2, 3 on this side and 1 on this side,
Start at 5 and then go to 9,
you want to go to the 5 and then the 9, 9,
9.
like that.
No, up.
I'm at the 9, 9.
Oh.
Now I'm 1 and 1 because it kind of touches, doesn't it? This one? Or we could go a little bit this way. I think that this one was probably our best bet, wasn't it? I can't go here. There. There. How about here? How about those two? Not so much. So we're gonna go with the 9 and the 5. You guys want that as your best line of fit? Look pretty good? All right, that's the one we'll use. Okay, now let's graph this. The table shows the number of hours students spent studying for a math test and their corresponding grades. Well, first thing we need to do is label this. Create a scatter plot, meaning label it. What do you want to label it? Students' test grades. Students' test grades. What does our vertical axis want to be? Your y-axis want to be labeled what? This is x and y coordinates. The y is going to be your grade. Whoops. This will be your grade. And this will be the hours studied. Now notice we have a broken vertical axis here. So let's start out. Hours studied. Well, our range is what, 0 to 5, so we can go 0, 1, 2, 3. We can go by ones on our interval. How about the broken vertical axis then? What do we want to start at here? Our range is what, from 60 all the way up to 92? You want to go by tens? So do you want to go 10, 20, 30, 40, 50, 60, 70, 80, 90? Or is that going to be kind of, how about if I were to start at 50, what could I go by? Actually, let's start at 55. Yep, then we can go by 5s. Because it looks like these are pretty good. So we'll go by about 5s. 55, 60, 65, 70, 75, 80, 85, 90, all the way up to 95. That covers our range using those intervals. All right, now plot your points. 3 and 84, well, we know exactly where 3 is. We're going to have to kind of estimate where 84 is. That won't be too hard, right below the 85. 2 and 77, a little bit above the 75. 5 and 92, all right there. 1 and 70, that's easy. 0, 60. So it looks like they studied 0 hours and got a nice little D- on our test there. 4 and 90. And 3 and 75. Now we have our data. we've created our scatter plot. Now we need to draw the trend line. Where do you kind of want to go from on your trend line here? You want to start at the 060? How's that? I went from 060 up to the 4 and 90. Does that look pretty good? Or could it be better? See what happens if I move it down to this one. Better or worse? Worse? How about there? This way? You want to stay with that one? Do you want to move this one? Are you moving your protractor around to see which is best for what you're seeing? Do you like that one? Not so much. I think our original one again, wasn't it? Going through about right there.
How about go through the 277?
Go through the what?
277, and then the 592.
And the 5 and 92. You like that one? 3 and 2. That one could work also, couldn't it? Which one fits the better pattern, do you think? Which one do you think fits the better association? Because here would be our association going this way. Which one do you like? That one? Which one? Either one I think would have been pretty close, wouldn't they? So I would probably accept either one on that one. Alright, let's answer the questions. What does the y-intercept represent in the context of this data? What does the y-intercept represent? It represents the grade the student received. What does the slope represent? It is a positive slope and according to the line of best fit, what grade would you expect to receive if you studied 2.5 hours? Blurt it out. What do you think you would get? Approximately? Probably going to get what? Approximately what between what and what? Between 75 and 80% we're looking at? Approximately? All right, now there's no graph with this one, but we can still answer the questions. We have an equation, y equals 15x. Ooh, what don't we have there? We don't have the y-intercept, but it actually is what? 0. So instead of Sandy's Donuts, it's Randy's Donuts, and they decided to start a Twitter account. X represents the number of days since they were open. Y is the number of their followers. So what does the Y represent in the context of this data? What is Y? That's the number, how many followers they have. What does the slope represent in the context of the data? What is the slope? What is the slope up here in this equation? 15. What does 15 represent then in this equation? The number of followers added what? Yes. The number of followers added per day. Period. So with that information, using this equation, approximately how many followers will Randy's Donuts have on Twitter after the 25th day? What do I need to do? Y equals 15x. What do I need to do? Plus 25? Is that what I want to do?
Subtract 25.
I want to put 25 in for my x. That means y equals 15 times 25. What does y equal? $375? 375 what? Followers. Your homework is pages 8, 9, and 10. Pages 8, 9, and 10 in the packet.